Hi, my name is Alex George, and I'm an engineer at Immunity. Earlier today, July 15th, we recorded a demo demonstrating how we used Canvas to help test the efficacy of antivirus products by using Canvas's remote exploit capabilities. During that particular demo, we had a technical issue with one of the VMs, so we decided to re-record it after that issue had been resolved and hopefully make the demo a little bit clearer. During that demo time, we had two questions that were posed by the attendees. I'll be repeating those questions and my answers to them during the appropriate moment. So without further ado, I'm going to share my desktop and we'll get started. Okay. All right, so what we've got here is a copy of Canvas. And what I'd like to do is begin by talking about how we've got our VM set up. So essentially what we did was I had a Windows XP Service Pack 2 VM that I used extensively during the Q&A process as well as demoing. And what we did was we cloned that VM to create 4 separate and distinct VMs. Then I went to my local office supply store and I picked up 3 major name brand antivirus solutions. Now, each of these solutions, according to their advertising, promised a few different things in their own manner of speaking. First, that there would be real-time protection. There's a heuristics component to that engine, as well as protecting you from network-based attacks. So what we did was we installed each of those antivirus products on its own separate VM. And then for the 4th VM, we went out onto the web and found a very popular free antivirus solution. We installed that, and then for each of the VMs that we're testing, after the antivirus installation, we allowed them to come up to their current versions and current antivirus definitions. Now, it's worthwhile to note that these were not trial editions of the software. We purchased this, registered them, so we had access to the latest and greatest patches and software updates for these products. Once they were installed, we did a simple test to see if we were able to, from another client on the same network, just browse to those systems' file shares. In a number of cases, we were not able to. So we reconfigured those antiviruses to allow for file sharing. We did this by going to the vendors' websites, looking up how this was done, and following those instructions. The other thing we did was we lowered the timeout, I should say, or the amount of time a blocked host would be on a block list. Sometimes we could eliminate this entirely. Other times we'd have to wait a minimum of a minute. Now, the reason we did this was to, well, frankly, save us some time. Because once we found, all right, there's a combination of Canvas settings that did not work, we want to be able to adjust the settings and retest as soon as we could. So with that in mind, let me just talk about Canvas and some of those settings. The exploit we're using is simple MSO 8067, tried and true, been around for a long time. This was the Sasser worm. This should be on everybody's radar if you're an antivirus company. The next thing we did was we looked down here at the covertness bar. Now you'll note covertness is currently set at 1. What that means, and I should say our covertness bar goes up to 11, but what setting 1 means, Canvas is sending out the exploit as fast as it can with no regard for being stealthy or covert. The farther you bump this up, a couple things happen. Microsoft supports fragmentation at the application layer for the SMB protocol. What this means is we're able to stretch out our request over a bunch of packets. As a for instance, to successfully go from 0 to shell using MSO 8067 at covertness 1, you're looking at in the order of 100 and 150 packets. When you go from 0 to shell at covertness set to 11, you're looking at a couple thousand packets. The idea here is that if we can allow the operating system to take care of, the service in this case, to take care of reassembling all these particular fragments, and then still have a workable exploit, what we're doing then is saying, all right, well, we're making the antivirus, in this case, is going to have more trouble doing that type of reassembly than the operating system would. The other thing we do is we slow down the rate at which we send packets. If we can take advantage of state limitations for that particular installation, that works in our favor as well. our goal is to get the shell, and then that's what we're evaluating it on. So the first piece we're going to look at is the VM called AV1. This contains the free antivirus product. So to test it, all I'm going to do is I'm going to leave covertness set at 1. I'm going to say Windows XP Service Pack 2 to 3 as my particular target. Set it for English in this case. And then I'm just going to let it go and see what happens, and see if we get a shell back. And as you can see, if you're very familiar with Canvas, this is the standard startup messages that you see where we're finding the addresses of different functions we need in memory. You can see there we go. We've got a shell, no problem. So next we're going to do is we're going to move away from the free and then into the paid. So in this instance, this is a very, very well-known antivirus vendor that claims to offer some protection from these types of attacks. And we'll note we're not using any tricky covertness settings. We're just simply going to try the exploit and see if it works. So now I've set my new target. I'm going to try this again. And we can see we basically have the exact same result as we did before. Our shell starts up with no problems, and we're going to be able to browse and do post-exploit actions. So one of the other things to consider is that your exploit may be successful, but antivirus may stop your callback from occurring. That's another very common tactic. In this case, we were able to establish our shell and have our callback, but we don't know if our shell was killed later on in the process. So to check that, all I'm going to do is just run a fairly intensive command. We're going to look at the file system browser. If you'll pay attention to the Canvas log window, you'll see I am interacting with host memory. I'm finding new functions, etc. So this shows me that this shell is, in fact, still alive. I can also do the very simple Canvas test that we advise everyone do and just grab my current working directory. No problem. So we know that, okay, this is a successful intrusion. So the next thing we're going to do is look at our next target, which is a separate antivirus, and we're going to see what happens. Set it 1. Okay, and again, we see that this is actually able to work. Now, this brings up an interesting point. With this specific antivirus vendor, one of the things that we noted was that sometimes we would have actually very poor success against this antivirus. Sometimes we'd have very good success. What I mean by that is that we really have to spend a lot of time playing with our covertness settings in order to get a shell. In this case, however, we're able to get a shell on the first try. We can run just our little test again real quick. And we can see, all right, this is an active shell. All right. So the next one we're going to do is our final antivirus example. And we're going to see what happens. So now, this is a very interesting issue. We can see if we just, let me maximize my my Canvas window here. And if I scroll up, I can see a couple things. All right, so I'm attacking, my Canvas log says, all right, you're attacking this particular host with this exploit. I scroll down. All right, I'm going to try to connect to this endpoint. I was able to connect to that endpoint. I did send my attack. And now, Canvas believes that, all right, I should get an attack reply. I should set up a shell that will wait for me, wait for the connect back from this exploited host. However, it never comes. So I see this has failed. So what I can do now, just as to follow the methodology that we use during testing, is I'm going to increase my covertness to 11 and see if my results change at all. We're going to do the same host, the same everything. We're just going to change the covertness level. And I can see, again, I'm able to connect to this endpoint, but I still come back to the same problem. Canvas believes that exploit should be successful. However, it never actually returns a connect back. Now, if we open this up in Wireshark, we could examine it. Essentially what happens is as soon as we're done setting our attack string, we get an RST back, meaning that this particular antivirus product does work as intended. it's able to find our attack and stops it by way of RSTing our connection. So now where does this leave us as an attacker? Well, the first place this leaves us is we could look at trying to further obfuscate our traffic. We could look at, SMB supports encryption. We could look in that direction, but that's going to be topics for another demo. Now, we had two questions from the original demo. The first was, would this methodology be suitable for PCI? For example, if you want to test your CSA, HIPS, or AV installation. My answer to that was yes, this is a very strong use case for Canvas because you can employ, it's not just going by what the vendors claim to do, you can actually empirically test, does this work or not? The second question we had was, for all the VMs, are real-time and heuristics options enabled? The answer is yes. The only configuration that we did was to allow for file sharing. We did not modify, we accepted essentially just all the defaults for all the installation, modified it as I mentioned further. So if the antivirus product itself, all of them, again, advertise real-time and heuristics in their own particular manner of marketing speak, we left those options alone. The follow-up question to that was, do they detect in-memory threats? It is a little bit murky whether or not they do, based on some of their advertising language. For two of them, yes, they definitely do. For one of them, it talks about that, but it's not incredibly specific using those exact terminologies. So I'm going to go ahead and venture that, yes, these do something that you would consider detection of in-memory threats. All right, so that'll be it for the demo today. We hope this has been informative and lays out for if you want to test your own antivirus or intrusion detection technology, you're able to do this fairly effectively and repeatably with Canvas. Everything that we've done here can be scripted out with just a little bit of knowledge of Python and Canvas, and it's something that Immunity we're more than happy to help you do. So thank you very much for your time, and we'll stop the recording.